The gastrointestinal or GI tract serves as the main site of digestion as well as absorption of nutrients and medications. A layer of cells in the GI tract, which we call the GI epithelium, helps protect our bodies from external pathogens like viruses, bacteria, and parasites, as well as provide the main site for digestion and absorption of nutrients and drugs. In the GI epithelium, we identified a specific enzyme called catalase, with the capacity to turn individual monomer building blocks into polymeric films. Specifically, we focused on the adhesive system that muscles use for sticking to rocks and developed a system where we could ingest the building blocks, in this case dopamine, of the adhesives and have it form an adhesive film, polydopamine, on the surface of the GI tract. To ensure rapid formation of these adhesive films, the dopamine solution included low amounts of hydrogen peroxide, lower than is found in toothpaste, which is broken down by the intestinal catalase and provides oxygen, which is needed to help form the films rapidly. We call these films gastrointestinal synthetic epithelial linings, or G-cell. We studied the presence of catalase in all segments of the GI tract of pigs, but also in human tissue, and found that higher concentrations of the enzyme were present in the first part of the small intestine. Using these new G-cell films, we developed a liquid system that could be taken by children and adults that could help deliver medications for a whole day by having the drug remain for a longer period of time on the surface of the intestine. We showed this with a specific medication called praziquantel that is used for the treatment of parasites, which usually needs to be taken 3 times a day. Using G-cell, we were able to convert this dosing to once a day by increasing the half-life of the drug by 10 times. Additionally, with G-cell, we showed that we could also provide enzymes to better help with digestion. We focused our efforts on lactase, the enzyme that helps break down lactose, the main sugar found in milk and milk products, recognizing that lactose deficiency affects greater than 60% of the population. With G-cell, we showed that we could enhance the breakdown of lactose 20 times over the baseline in the intestine. Also, we demonstrated that using G-cell, we could form a barrier in the intestine to help reduce absorption of glucose and therefore serve as a new potential treatment for diabetes and obesity. From a safety perspective, we tested the G-cell system in rats as well as pigs, and reassuringly did not find any initial safety concerns. In sum, we present a new system that can be turned to help facilitate the taking of medications, support nutrition absorption through enhanced digestion, and potentially help treat obesity and diabetes. We are indebted to our sponsors for their support of this work, specifically the Bill and Melinda Gates Foundation and the National Institutes of Health.